Now we finally get to fronts. So fronts are bringing back the idea of air masses, which we discussed the other day. And an air mass, we said we could have a warm, dry air mass, we could have a cold, dry air mass. So when you have two air masses that are coming into contact with one another, there's going to be a boundary. And that boundary is what we refer to as a front, right? So that's a region between two air masses of different density. Now, you may have heard about a cold front moving in or a warm front moving in. When a cold front moves in, we're going to see that we're going to have cold air behind, but it's going to actually push up and out the warm, moist air. And that's where my favorite cloud, if you remember, the cumulonimbus cloud, will end up forming. And you're going to get some heavy rains, you get those strong winds. So it's a lot of fun. That's where we can get some cool thunderstorms. But we're going to get into that in a second. So now as you go through what I just described to you, now you see in a picture. Cold air mass pushing in, warm air mass getting bulldozed up and out of the way, creating that cumulonimbus cloud, and then you get the heavy precipitation. Right, so again, this is a cumulonimbus. Cumulonimbus cloud, right? And that's going to have heavy precipitation. And I would even expect some lightning if conditions are really good. All right. Now, go ahead and take a second and fill in what it says in those notes so that you understand, right? When cold, dense air displaces, meaning forcing upward warm air. It forces the warm air, which is less dense, up along a steep slope. And that's what I said was the bulldozer, the steep slope. Think about a bulldozer coming in. That's almost a completely flat, almost 90 degrees panel that pushes soil. So here we have this sharp angle that's forcing the warm air up and out. But wait, there's more. Here, you guys can see a warm front moving in. Now, a warm front gradually overtakes a colder air mass, or basically replaces that colder air mass. And as it does that, you can actually get clouds forming and steady, kind of annoying precipitation to follow. Right? So you're going to have warmer temperatures. Notice, I forgot to point out before, the symbols are on the left. So over here, you can see they look like little suns on the front of the line, and it shows the direction that that air mass is actually moving. So there's your cold front symbol. Warm front symbol. I'm just going to pull down for a second. Here you can see the cold front symbol. Right, it looks like little icicles. Those will be testable items. Right, make sure you can identify them. All right, so two fronts out of the way. Let's keep going. What happens if a cold front can't overpower a warm front? Well, in that case, you end up with a stationary front. And the stationary front, you can actually tell from the symbol, looks like a warm pushing against a cold. That's why you have the alternating sides. And basically, you have these air masses that have now stalled. And if you're thinking, like, why would it stall? Well, just because you have a cold air mass and a warm air mass doesn't mean that there's a huge difference in temperature all the time. So if the temperatures are relatively close, you might not get that power from the warm front or the cold front to push the other one out of the way. So think close range in temperatures and the stalling or not moving of an air mass. So we might get the same weather for an extended period of time because of this phenomenon. And then we get to the occluded front. Now, when I think about an occluded front, I think warm air mass was trying to overtake a cold air mass. So you had a warm front going on, and then another cold air mass pushed in behind even faster. And they basically merged the two cold air masses, which you guys can see down on the bottom. Over in here, you got the two cold air masses that have now sutured together and picked up the warm air mass. So now the warm air mass is basically piggybacked on top of the two colder air masses. So that's what we call an occluded front, right? The warm air mass has been separated from the ground surface and is riding on the backs of two cold air masses. And here, think about what would happen if I took the symbols of a cold front, blue, and a warm front, red. When we blend the two together, we end up with this purple, and you see that rather than the stationary front, which you had alternating sides, now you have an alternating symbol on the same side. So again, these symbols are pointing in the direction that the air mass is moving. Right, the air mass is moving this way, or the air masses in this case are moving that way, and you get those alternating symbols. So a couple points I just want to hit home on. The diagrams that you just saw of each front, definite quiz test material. If you haven't figured out, and now it's February, I love diagrams. Right along those lines, the air mass diagram, right? I'll give you a picture of the U.S. and I'll put letters over the central U.S., this up in like Canada, and then over the ocean, like the North Atlantic, North Pacific, or down around the equatorial region, and you should be able to tell me if it's maritime tropical, maritime polar, continental tropical, continental polar, and then we also have the Arctic up in the tundra up by the pole, like the polar region. So be ready for that. Don't worry, I'll give you that diagram when we're together next.
Now let's take a second to come back to this idea of pressure and pressure systems. So we remembered that due to the Coriolis effect, we can have high pressure, go to low pressure, and in the northern hemisphere it's going to curve to the right. If we have low pressure, and then we have high pressure, high pressure, high pressure, high pressure, well, the winds are going to curve to the right, curve to the right, curve to the right, curve to the right. You're like, okay, why did he just do that? Because this is actually what creates the counterclockwise rotation for hurricanes in the northern hemisphere. Tornadoes, similar phenomenon where we're going to get this counterclockwise rotation. And this counterclockwise rotation occurs because you have a center of low pressure and high pressure areas trying to push into that low pressure. I think about this like a vacuum cleaner. Again, the air is being drawn up, creating a void underneath, and more material gets pulled in there. The opposite of that would be if I have a center of high pressure, that would mean that I have low pressure all around. And therefore, winds again are going to move outward. But now this is going to create a general pattern of clockwise rotation. Now, I always encourage you guys to draw out the little things that I talk about. But when you do that, I would put these letters with it. Hawk and lick. And lick and hawk are ways of remembering that when you have a center of low pressure, air is going to move inward, and you're going to get counterclockwise rotation. Lick. When you have high pressure, winds are going to move outward, and you're going to get clockwise rotation. So that's your hawk. Now I just gave you a quick overview of what we're talking about. Now, let's actually see what the notes say. Here it says, sinking or rising air, combined with the Coriolis effect, that was the curving to the right, results in the formation of rotating high and low pressure systems in the atmosphere. Air always flows from an area of high pressure to an area of low pressure, and we just reinforce that. So I'm hoping this little sketch helps you to understand the concept. Now let's see it in picture form. All right, area of low pressure, winds are moving inward, curving to the right, creating counterclockwise rotation, the air is rising up. All right, so here, just to bring it back, we just said we have lick, L-I-C. And if it helps you to remember, you put like a little C for counterclockwise. Okay, when we look at the next one, here you have a center of high pressure, so air is sinking down, it's moving outward. This is where we're going to get hawk. Right? High pressure, outward moving, clockwise rotation. So this brings us to the end of this section. I apologize if there was any issue with the lesson yesterday, but at this time, make sure that you've gone back and filled in any of your notes. I will come around and check that your notes are complete up to this point on Thursday during lab. Okay, so lab day for period 1, lab day for period 7. Friday, I'll do lab day for period 3. Okay? Go ahead and get started on your homework, and have a great day.